ask yourself, if you had x squared minus 3 over 4, what would you do?
Sorry for the interruption. Would all grade 12 students and their teachers please go to the library after
And their
the
teachers.
theater after you've done attendance? That's all grade 12 students and their teachers. Please
I'm a
to the
student.
theater after attendance is done. And teachers, if you have a split class, just stay with your class.
Oh, they got a collection.
Did you ask them to put that in there?
All right, so
Insider trading.
grade 12s, you'll watch the video when you get back. Now, if you were solving this,
Yeah.
you'd get this by itself and you would square root.
This is unjust. That's all lockout right now.
So if that's how you would do it with x squared, you would do the same thing with the sine squared. You move your 3/4 over. You would square root both sides. And then from grade 10 and 11, you have to know all of your square root rules. So the square root of a fraction is the same as the square root of the top over the square root of the bottom. And square root in the bottom just becomes 2. And that is on your unit circle. What family has root 3 over 2 for sine? It's your pi over 3 family. And because it's plus or minus according to your cast rule, you would look in all 4 quadrants. So we'd have in quadrant 1, in quadrant 2, in quadrant 3, and in quadrant 4. So when we have an equation with trigonometry and it's squared, you're going to be solving it in the same way that you solved trigonometry or solved quadratics in the past. Factoring, you might have to use the quadratic formula. So this is a trinomial. Your options are either quadratic formula or factoring. If you factor, usually factoring in grade 12 is easier than factoring in grade 10 and 11. They give you easier numbers. So one of the things that I use when I'm factoring is I say to myself, when you multiply things out, whatever your first ones are, so the first one here and the first one there, will have to give me 2 sine squared theta. Whatever my last ones are going to have to give me 1. And if I multiply the outside and the inside and combine them, I'm going to get minus 3. So I'm going to think this through and see if I can figure out which one goes with which. Well, the only way to get 2 sine squared theta, there's only one option. It has to be 2 sine theta and sine theta. So if this can be factored, we don't know for sure yet if it can, but if it could, that's our only option. So that makes our life pretty easy. Then I look at my last one, which is a 1. And if I'm going to get 1, this has to be 1 and 1. That's the only way with whole numbers, and we never in factoring, we never go to decimals or fractions. We always just use whole numbers. It has to be 1 and 1. Now the last thing, you're going to check, can the outside and the inside make minus 3? Yes, if they were both negative, right? Negative 2 on the outside, negative 1 on the inside. Double check if the last one still works after you do your signs. Is negative 1 times negative 1 still positive 1? Yes. So this is the process that I like to use for factoring. I look at my first ones, I look at my last ones, then I see if the outside and the inside can combine. And after I factor, I always double check it by multiplying it out, just make sure that it works. Using that method, you'll get better and better at factoring all the way through. Now, if this one was equal to 0, does it make sense that you could, technically, you could write this out. Because when you change something to factoring and it's equal to 0, either the first one equals 0 or the second one equals 0. And in green, if the first one's equal to 0, do you see that I move the 1 over and divide by 2, and I get sine theta equals 1/2. If the second one was equal to 0, right, and again, normally we don't write this step in green, but this is what we think in our head. If it's equal to 0, does it make sense that sine theta would equal 1? This would be a non-calculator question. Is half on your pie plate? Yes. What family?
Pi over 6.
Pi over 6. So at a certain point, I'm going to do this in green too. Some of you might write the reference angle down, but it's not necessary. You could have that also in your head. And you could go directly to the answer and say, okay, I know it's my pi over 6 family. I know sine is positive, so it'll be in quadrant 1 and quadrant 2, according to the cast rule. Sine is positive in quadrant 1 and quadrant 2. May as well write the cast rule up here just to keep it in our mind. Is the y coordinate ever equal to 1?
Yeah.
Yes, that's an axis family. Which place? Y coordinate equal to 1, that's up here, is it not? So what angle is that? Pi over 2. And again, if I go back to A, because this is something, after I do every single question, I always check where did they want me to solve. And every single question, A, B, C, D, that we're doing here, we're just going once around the circle. That's the most common. Of course, the textbook likes to mix it up a little bit when you do the homework questions. But it's very common to check between 0 and 2 pi. Now, if I change this to algebra, part D is asking the following. Solve minus 3y minus x squared minus 3 equals 0. And in grade 11, you were not allowed or not able to solve that because you had 2 variables. You have an x and a y. If you have 1 equation and 2 variables, you can't solve. But remember the whole unit that you did with multiple equations? If you had 2 equations with 2 variables, you could solve. And you had techniques like substitution or elimination. The hard part in trigonometry is that they could give you this and expect you to remember the big idea. One of our big ideas was that sine squared theta plus cos squared theta is always equal to 1. That gives us a second equation. And if you have 2 equations with 2 things you don't know, you can use substitution. The substitution that you will always do here is a rearrangement of this formula. Does it make sense that I could get the sine squared theta by itself by moving the cos squared theta to the other side? Or I could get the cos squared theta by itself by moving the sine squared theta to the other side. I'm going to put a green box around this one because in my first equation I have, I'll put a green box around that, a cos squared theta. This allows me to do substitution. The way that substitution works is you rewrite everything. Minus 3 sine theta minus, and now instead of cos squared theta, I can write, based on that green box, 1 minus sine squared theta instead. And then I still have minus 3 equals 0. The brackets are important because this negative sign will distribute to both of those. And I'll have minus 3 sine theta minus 1 plus sine squared theta minus 3 equals 0. Now I have an equation just with sine. It's quadratic. So I can factor, I can use the quadratic formula. Before I look at either of those, I like to write my quadratic equations always with the squared thing first. Then I'd have minus 3 sine theta. Minus 1 and minus 3 are like terms. Minus 4 equals 0. I don't know if I can factor this, but I'm going to try. So since my first one is sine squared, the only option for my first ones would be sine theta and sine theta. My last number is a 4. That gives options because it could be 2 and 2 or 4 and 1. So then when trying to put the numbers here, you're also thinking about the outside and the inside combining to give 3. Can you see right away if I do 2 and 2? My outside's 2, my inside's 2. There's no way I'll ever get 3. But if I try 4 and 1, my outside would be 4 sine theta, my inside 1 sine theta. I want to get minus 3. Can you see that you could do that with a minus 4 on the outside and a plus 1 on the inside? Double check, does the last one still work? Yes. Split it up. If this is equal to 0, then sine theta would be negative 1. If this is equal to 0, then sine of theta would be 4. This still would appear on your non-calculator part of your test. Is 1, negative 1 on your pie plate?
Yeah.
Yes, axes family. What angle is the y coordinate negative 1?
3 pi.
3 pi over 2. Is 4 on your pie plate? No. So the first thought is, how can I do this without a calculator? Because this value is not on my pie plate. But it's still possible to do. Okay? If you had a calculator, what would you do?
Inverse.
You do inverse sine of 4. Okay? So if you have a calculator, you can try it, you'll get a hint. If your teacher asked you to draw a picture of what's happening, sine of theta is what over what?
4 over 1.
4 over 1, which is, if I draw a right angle triangle, how would I label? Here's my angle theta. What would I do?
4.
4 on this side,
1.
1 on this side. Now can you see how you could solve it without your calculator by drawing a picture? Is there something weird about that triangle?
Don't.
It's not possible. Can you have a hypotenuse smaller? Isn't the hypotenuse always the biggest side? So the reason this can be done without a calculator is because it's actually not possible. For sine and cosine, anytime you get a number bigger than 1, or a negative number less than negative 1, like negative 2, negative 3. In other words, if you have the number, ignore the sign, positive or negative, if the number itself is bigger than 1, it's going to be not possible. And they'll expect you to know that on a non-calculator part. Drawing the triangle makes it really obvious. It's like, I don't think I can draw a hypotenuse of 1 if my side is 4. Okay, let's get to some calculator questions.
What should on calculators be
In radians, because this question said from 0 to 2 pi.
can you help me put it in radians? I have no idea.
So depending on your calculator, there's going to be a place that is a mode or a setup. On this one, try the mode button. And now we'll go to setup button. Setup button's above the mouse, so second setup. And then DRG on 0. That's your switch.
And then
So
can I just make it on radians for like
So on this one,
the rest of my life?
here goes shift setup. And then 3 is degrees, 4 is radians. So you have 4 and 9 are radians. Yes, same thing in motor. So you will have to switch between degrees and radians.
I feel like degrees is more useful. Like, this is more. Like, when would you have a protractor?
Okay.
Instead of yeah, like, rather, I think this is hard. Three.
Now, in order to use either the quadratic formula or factoring with a quadratic, you need to make one side equal to 0. So I make one side equal to 0. And I'm going to show you how to factor this one. And then after this, we'll do one where we use the quadratic formula just to practice that as well. Okay, but this is a harder one to factor. In fact, some people don't like this when the number is bigger than, like that first number is a 6. It's a problem. Can you see your first one has 2 options? It's either 6 and 1 or 2 and 3. And sometimes when it has more than one option, you're like, you know what? I'm just going to use my quadratic formula because I don't want to do the mental math to try different options. Okay? For me personally, I would still do this one. I would actually start with the last one because the last one doesn't have 2 options. It has to be 1 and 1. I would write that first. Then, when I look at my first one, either 6 and 1 or 2 and 3, it's not that hard mental math to see that 6 and 1, outside 6, inside 1, does that ever make 1? No. But 2 and 3 might work. So I go 2 sine theta and 3 sine theta. My outside right now is 2 sine theta, my inside is 3 sine theta. If I want a positive 1, does it make sense that my 3 would have to be positive? And my 2 would have to be negative. 3 minus 2 gives me a positive sign. I double check everything and multiply it out. I still will get my 6 sine squared. I still get my minus 1 for my last ones now with the signs there. And my outside and my inside make plus sine theta. So even though this one was supposedly a hard one to factor, because we could start with the last term, it actually wasn't too bad. Okay? If either your first number or your last number is a prime number meaning that it's only multiplied by itself and 5, technically 1 is not a prime number. First prime number is 2, but 1 is still only 1 times 1. Then factoring is the easiest. If both of the numbers have lots of options, I'd probably say go to your quadratic formula. And we'll do a quadratic formula one next to see what that looks like. It's going to be messy, I'm just warning you. It's going to get a little messy, but we'll have some fun. Now, if this was equal to 0, right? In your head you think this. If this one was equal to 0, then sine of theta, I move my 1 over, get negative 1, divide by 2, get negative 1/2. If this one was equal to 0, I move my 1 over, divide by 3, I'd get 1/3. This would be a calculator question on your exam, but on the calculator questions on the exam, they would say, if you know the exact values, still do them. So like a half, you're like, hey, that's on my pi plate. I know. That's my pi over 6 family, right? Then for sure, for this side, don't use your calculator. You know it's your pi over 6 family. You know it is negative, so according to your cast rule, we're going to be looking in quadrants 3 and 4, because that's where sine is negative. And I would say, what are my pi over 6 in 3? 7 pi over 6. What's my pi over 6 in 4? 11 pi over 6. Perfect. This one, 1/3, not on your pi plate. So what we need to do is we need to find our reference angle, and we do it just like we would have in grade 11. And I'll type, like in grade 11, you normally don't write this step. But that's what you're going to type into your calculator. Sine inverse of, and just a note, for figuring out your reference angle, you always plug in a positive fraction. Our fraction was positive already, so we didn't have to worry about that. But if this question had sine theta equals negative 1/3, you would find your reference angle by doing sine inverse of positive 1/3. Take out our calculator.
607.
And make sure my calculator, I'm going to hit the mode button if you have a graphing calculator. And push enter on radians to make sure I'm in radians. And then I go second sine inverse of 1 divided by 3. And I get 0.340. That's our reference angle. 0.340. I'm going to write 339 ... just to show that I'm not rounding it early. Using all of the decimal places until I get my final answer. Okay? Then, what are my answers to 3 decimal places? Well, sine is positive here. We would look in quadrant 1 and quadrant 2. In quadrant 1, rounded to 3 decimal places will be 0.340. In quadrant 2, in degrees you would have done 180 minus your reference angle. So in radians you would do pi minus your reference angle. And sometimes you can highlight it. Sometimes you can go second answer. That way it keeps all the decimal places. 2.802. So we round to 3 decimal places. Without your calculator, first of all, do you remember roughly how many degrees 1 radian is? 1 radian is
57.
57. Good. 57.3 if you want to be like really light. So, but 57 degrees. So can you estimate for me how many degrees this is? I know, 0.34.
1.
Close. Yeah. 20 would be close. 0.33 is like a third, right? A third of 57 would be 19 degrees. That would be a good estimate. In fact, if we went to our calculator, how close are our estimates? If we go to our calculator, change our mode back to degrees. And I did this question again, 19.47. So 20 degrees, 19 degrees, both very good estimates. Okay? All right, I'm going to switch back to radians because I'm going to do one more question that I don't think you have any more written down, do you?
No.
Okay, that means I get to make up one, which is fun. One where we have to use the quadratic formula. All right, let's go with tan squared theta minus 3 tan theta plus 7. Do I want to go plus 7? No, I want to go minus 7. I think you'd love it if I kept plus 7. I'm going to go minus 7. Equals 0. Can we factor this? Absolutely not. If you tried, the first ones would have to be 10. The last one's a 7. It would have to be 1 and 7. Your outside would be 7, your inside would be 1. Does that ever make 3? No. So we have to use the quadratic formula. The quadratic formula is on your formula sheet. I believe it says this. Someone has their formula sheet, take it out. I wonder, does it have this first part, ax squared plus bx plus c equals 0? Does it have that? Yes, it does. Oh, but 4 is capitalized, and there's a comma. So I better fix that. On your formula sheet, there's a capital F,
Oh, okay.
and there's a comma here. There we go. Now you guys are set. Okay. How do we use the quadratic formula? Do we have an x squared? No. We have a tan squared. So instead of x equals, we are going to write tan theta equals. Your b value, -3, -3 will be a 3. Plus or minus square root. -3 squared, 9. Minus 4. A value, what's in front of the tan? A 1. Times by the c value, which is a -7. Over 2 times 1, which will just be 2 on the bottom. I'm going to simplify the inside of that square root. Tan of theta equals 3 plus or minus square root of 7 times 4 would be 28. 28 plus 9 is 37. Okay. Is either 3 plus the square root of 37 over 2 or 3 minus the square root of 37 over 2 on your unit circle? No. This is definitely a calculator question. And that plus or minus, I'm actually going to split it up here and write them separately. You have one where you have to solve with the plus sign, and one where you have to solve with the minus sign. And both of these are a little bit tricky to work with just because how they're written. So it's not bad, since it is a calculator question, just to get a sense of what is happening here. I'm going to type these fractions into my calculator, see what they're equal to. If your calculator has a fraction button, use it because it's super helpful. So mine, I can get the fraction button by going alpha y1 and pushing enter, and I get the fraction. Then I can go 3 plus the square root of 37 over 2 and push enter, and 3 minus, let's change that to a minus sign, 4.541. Am I going to remember these? Yeah, I think so. And -1.541. Are they on your pie plate now? Still no. But unlike sine and cos, tan can be anything, because you think tan is your opposite over adjacent. Could your opposite be bigger? Absolutely. Could your opposite be smaller? Absolutely. Tan actually exists for every single number except 90 degrees at the top and 270. Those are the ones that are undefined. But any value that you have, you can always find theta. So here, just like the last one, even though they're ugly numbers, we still need to find our reference angle for both of these. We'll do this one first. So I need to do the reference angle tan inverse of that. So when I go to my calculator, I can go tan inverse, and I can either take this 4.54 and type it in with all the decimal places, or I could take the fraction and type it in. Both would be okay. I push enter, and I get a reference angle of 1.354. Dot, dot, dot. According to my cast rule, according to my cast rule, I would be looking in, tan was positive, I'd be looking in quadrant 1 and quadrant 3. So my actual answer here, well, quadrant 1 will be exactly the same. I should double check, did it round to 5 or did it stay at 4?
4, I think.
I think it stayed at 4. Yeah, it stayed at 4. And then in quadrant 3, I would do pi plus my reference angle, pi plus my answer, and I get 4.496. We do the same thing on the other side, but on the other side, we do tan inverse, but we do, you don't have to write that positive sign, but I'm trying to be really obvious that every time you do a reference angle, it's always tan inverse of the positive angle. Now, if I go to my calculator here, because I had that value before, I'm going to go tan inverse. And I'm like, I want to use this number without the negative. So if I push enter on that number, the negative's there. I have two options. I can either use my arrow button, go all the way back and delete it, and then go all the way back. And you wouldn't have to close the end, but you could do that. Or you could be like, hey, I know a trick. You take a negative number and multiply it by -1. Doesn't that make it positive? And that seems like less buttons for me to push. I push enter here, and I find out my reference angle is 0.995. There are lots of nice little tricks on your calculator. So, according to my cast rule here, I would be looking in quadrants 2 and quadrants 4 because tan was negative. So I'm going to have to, in quadrant 2, does it make sense that you would go all the way around to pi and minus your reference angle? In quadrant 4, you'd go all the way around to 2 pi and minus your reference angle. So I'm going to show you a nice little trick on your calculator. Once you get an answer that you know you're going to use more than once, above your on button is a store button. If you hit that store button, it says, where would you like to store your answer? You can actually choose any letter you want, A, B, C, D, E, F, G, whatever you like. I often just pick X because it's the easiest. I don't have to click a second button. So I can store my answer as X because now in quadrant 2, it'd be pi minus my reference angle, and I can just write pi minus X. Push enter. And in quadrant 4, it's going to be 2 pi minus my reference angle, so I can just write 2 pi minus X. It's a little bit quicker than going up and finding the answer that I had from before. So 2.146 is my one answer, rounded to 3 decimals, and the other answer was 5.288. These four answers are my final answer. So I can circle those.